in 2012 from Valencia University. After that, he had a postdoctoral appointment in IFN of Trieste for 4 years. And then he moved to US, where I've been a postdoctoral fellow in Flatiron. Then he's been a postdoctoral again in Princeton, but now he's still in Princeton as a visiting scientist, right? But then he moved back to Flatiron again and to the Simons Foundation, where he's now a research scientist from 2021. So from his webpage, I understood that he's a computational cosmologist, and he's applying many tools and modern tools in computational physics to, let's say, to learn and to answer about the fundamental question that are coming from the data, from the cosmological data. We learned last week during the colloquium that there is a plethora of new data that needs to be analyzed with new methods and so on, and he's the expert for that. And today's talk, that is promised to be very unconventional, is called the Denario Project, Deep Knowledge AI Agents for Scientific Discovery. Francisco, the floor is yours.
You can hear me, right? I think so, okay. So yeah, no, thank you very much for the opportunity to talk in front of you. So this is going to be, as you say, like a very unconventional talk. So, I'm going to try to do something that, is going to be, I think, might be very, I don't know, interesting at least. It's going to be also very polemic. It's going to give a lot of, I think, discussion. So it will be nice, for me, it will be nice if maybe, reserve some time really to discuss, because every time I give this talk, there is a huge discussion, and, feel free to really share whatever opinion, if it's really like good or this is like terrible. So, I think it's going to be a very interesting discussion. Okay, so first, just an advertisement for those of you that are doing cosmology. So we're organizing a conference next year in August, so more or less like 1 year from now. So this conference is going to coincide with a solar eclipse, just by coincidence. So, we are start the registration very soon. We are still in the pre-registration. We will have some support. For instance, if you are students, there will be some support. So, it's going to be a big conference. We are aiming for 1,000 people. So, if you are interested in this, it's going to be super beautiful. The eclipse is going to be at 8:30 p.m. So the sun is going to be like super low over the horizon. And yeah, hopefully we will be on the beach seeing this. All right. So this is the summary of the talk. So really the point that I would like to emphasize is that we are living in a really interesting time. But so I'm going to try to show you today that large language models have the potential to really change radically the way that we do science. And if this really happens, it's going to really lead to major changes, like structural changes, and maybe for good, but maybe not for good. So I'm also really concerned about these things. So let me start with the team, because I usually talk about this and I never forget, and this is really the people who are really doing the work. So Boris is a professor at Cambridge. He's one of the main developers of Denario. The same as Pablo Villanueva, who is working in Barcelona. Adrian is a postdoc in cosmology between Flatiron and Princeton. Pablo is working in quantum physics between CCQ and Google. Camille is working in chemical engineer. Chan is going to be a faculty is already a faculty, I think. He's a cosmologist. Raúl is also a cosmologist, working in Barcelona. Junjan is an undergraduate who is moving to Princeton. Thomas is a philosopher. I never in my life imagined to work with a philosopher, right? Never. I think you will see later why we are doing that. Pablos, I think, is working in machine learning at Harvard. Simanto is a student of Camille, also chemical engineer. Pedro is working with Raúl. Chi-Wan is a person working, I think, in the industry in DeepMind. So he's really, one of the developers of some of the software that we use. Likon is a student, I think, of Boris. Ki Yao is at Flatiron, but biology, the same as Anupan. Urbano, maybe some of you know. I think he was a student of you, Rogerio, many years ago. He's a physicist, but now he's working in Harvard Medical School, so he's doing other things. Wenhan and Bonnie are working in planetary science. Pablo is a biologist who is in all these institutions. Antonio is a mathematician, and I have to even put another slide because there are so many people. So, Jan-Fei is also at Flatiron, is an astrophysicist. Aidan, I'm not sure exactly what he does, but, we are working with, you will see later. So Jay is also an astrophysicist working in gravitational waves. And then, Almog and Yossi are neuroscientists in Tel Aviv. So let me go directly to the point. So as probably you know if you read the abstract, I'm going to try to write not one, but several papers live. So let me show you exactly what I'm planning to do. So, this is the folder where we are, okay? So I only have here, the code. So this is the code. I'm going to talk later about this. So let's go to project 1, okay? So here I only have one file. So let me open. And, this is what I have. Let me see if I can open this. So this is everything that is in this file. So what we're saying is that, we have there is a file, basically, that is located here. This is my laptop. I'm going to run almost everything on my laptop. And, this is basically like merger trees from cosmological numerical simulation. If you are not familiar with this thing, it doesn't really matter, some data from cosmology. And, this is basically the way that you read the data. And then what we are saying is that, what is this? These are like some properties of the data. And we are just explaining that, this thing represents the mass of the halos, the concentration, the maximum circular velocity, and the scale factor. It doesn't really matter. And there are some cosmological parameters that vary in this range. And then what we are saying is that, please come out with an idea to explore the data. Do not do something trivial. Sometimes it likes to do things. And just for to try to see if we are able to run this in 1 hour, I'm just saying to don't use like deep learning methods, because otherwise, in my laptop, it will not finish in 1 hour. So this is really everything that I have. And, I just have this thing, and I just have the data. Okay? So now I'm coming here. This is basically the code. The code is, cannot be simpler, right? It's like I'm just saying that, this is the folder where this file is, and I'm just saying, please generate an idea, please make a research plan, do the analysis, and write the paper. Crazy, right? So let's do it. So how is this called? Okay, I'm not in this directory. So this is Astropilot, Sao Paulo. Okay, so I'm just going to do Python run. And you will see. So it's going to start very soon. And the first thing that it's going to do is generate an idea. So I'm going to show you also exactly how it's doing this. So you see, now it's basically here. So let's open this file. So we have 2 agents. One is called Maker. That is going to put here the idea very soon. Let's see, just to make sure that it does. Okay. So this is the first thing that it's doing. I don't know if you can see. I can make it a little bit larger, but then it's not going to, I think, put the thing. So basically, it's saying that, let me see if I cannot read very well. So it's just saying, cosmological fingerprints, blah, blah, blah. So this is like the first. It's basically
a question. You already saw this idea or no? It's new.
No.
You don't know what this idea is. You are discovering with us this idea.
Exactly. So the interesting thing is that, this is an idea, and then, this is the idea, but then, it basically comes back to another agent who is going to criticize the idea. So usually it's very funny, the criticizing. So let's see your idea, blah, blah, blah. There are significant feasibility and detail issues that need to be addressing. This looks already like a referee, right? So you see, basically, one agent produces an idea, the other agent criticizes the idea, and then basically come back with the feedback to the first agent who is improving the idea, the critic basically keep criticizing this. Some people ask me, do they agree at some point? So far, I have never seen that they agree. This is like the worst referee that you can have. It will never be satisfied. So basically, after a few, let's say, chats, you say, okay, that's enough. And basically, I think probably, okay, so it's still doing, we have the maker and the hater. And actually, this is what we're going to do tomorrow. For those of you in the school, we're going to basically coding this thing. Okay, so it finished. And now this is the idea that it produced. So
You finish in which sense? That you put a cutoff
yes.
manually? Okay.
After 3 iterations, and it's like, say, okay, so whatever idea you have reached, let's use it. So this is the idea. Let's see what it's doing. Again, I have no idea what it's doing. So propose to uncover, blah, blah, blah. And it's going to use this. I mean, some of the things I don't even know what these things are. So global tree structure. OK, anyways. So that's the idea. So the next thing that it's going to do is basically make a research plan. So it's generating it. You will see it should take only like 30 seconds. And basically, it's like, given this idea and given the prompt that we use, it's like, OK, so what I have to do exactly in order to do this? So you will see that probably it's going to say that I need to read the data. OK, so it finished. So it has put now this file here. And you see, so it's doing some exploratory data analysis. So it's going to read the data. Then the second thing is going to do parallelized metric extraction workflow, OK? Then it's going to do, I mean, we will have to read this carefully, but statistical correlation analysis. But you see, this is like kind of an elaborate plan, OK? And the next thing that it's going to do is like, given this research plan, now it's going to come here. What it's going to do is basically for each of these points, it's going to write code, and it's going to execute code. And this is really, in my opinion, really amazing. For instance, it might say, OK, I need to use this library in order to do this code. It's able to, for instance, install the libraries by itself. Even like us, ChatGPT might produce a bug, might make a bug. So it's able to also correct the bug by itself. It's not magic. Sometimes fail, and there is a chance that they still might fail. But in principle, it's able to really do everything by itself. So let's wait. OK, so it's still doing things. I just want to show you maybe the first code that it's gonna write. This is gonna take like, hopefully 1 hour. By 1 hour, we will have a paper. And as I was saying, I don't guarantee that this is gonna be a good paper. It might be very bad. It can happen. But for instance, right now it's gonna do 6 steps in order to do all this research plan. And these are the first thing that it's gonna do. It's gonna load the 1,000 merger trees. It's gonna extract the features, blah, blah, blah. OK, so let's wait. Here in this folder, maybe in 30 seconds, or something like that, should write the first code. Oh, yeah, please, sorry.
So while we wait, I'm not a cosmologist, right? So anything that he writes that is complicated enough will convince me. But there are many cosmologists here.
Absolutely.
Is the idea sound, at least fairly sound and original enough?
I will have to
I mean, we didn't have the time to look, but if you put it up and people here look, is it sound enough? Because, that would be the first cut, right?
Yes. So let me see. I mean, I should be able to understand this.
Well, I mean, if you cannot spot problems in 5 minutes, it sounds enough.
I mean, this is kind of relatively generic, right? I don't think that just from this sounds anything bad. And
if it's good enough to fool you guys for 5 minutes, it's good enough. That's what I'm asking.
Yeah, I mean, I don't know. I don't really see anything here wrong, but it doesn't mean, it might tell you an amazing idea. I'm gonna solve quantum physics. Yeah, the idea is reasonable. I will say it's reasonable, but still, this doesn't guarantee that, when you get the final paper, it still might be a very bad one, or it might fail.
Do you have a benchmark of how many papers are good?
Right now, we have to do this with human feedback.
I know,
right?
I know, but do you have already some statistics to share on how many data?
I would say that out of 10 papers, 2 or 3 are reasonable.
Okay.
I think, if we were able, if we were able to
we have a question there.
But I think, if we were able to write 1,000 papers, one of them might be very good. Just for statistics. No, so, sometimes, the idea is good, but when it writes code, it fails, right? And, sometimes hallucinate. You say, I have done this, but it hasn't done this. So you have to be very careful. Yeah, please.
So on the technical side, when you have the idea generator and the critic, it looks a lot like a generative adversarial network. Is there anything like that behind? What's the technical side of that?
Yeah, exactly. So the idea here is that you have these two agents, and agents can either collaborate, maybe for a big purpose, or they can compete. So in this case, it's really a competition, but there is really no training. This is not like GAN, for instance, in the past. The only thing is that it's kind of like if you go to ChatGPT and say, okay, generate an idea. Okay, so you get the idea, and then you pass this idea again to ChatGPT and say, okay, criticize this idea. So it's really just that. It's super, super simple.
And do you have any, I don't know, again, any statistics if you start to increase the number of agents, like you say, 3 collaborates in criticizing and 3 collaborates, you improve a lot? You know anything about that?
So, I was reading this the other day. This field is moving so fast.
Yeah.
And so again, I don't want to say anything wrong, but my understanding, this is a super recent paper by Stanford. My understanding is that, they send all the agents to a group meeting. Seriously, they discuss between them, and apparently the more agents that you have, the more variety on ideas, all these things improve the quality of the idea. I think it's very hard to quantify this, and I need to read this carefully. Not really. So in our case, we use, like, for instance, OpenAI models, like GPT and this thing, but we also use like Gemini, the latest models. We use like Claude, Sonnet. I was talking with someone yesterday. In principle, we can use things even that are public available, or free.
Are these questions mostly data analysis, or is it actually like new theoretical ideas in cosmology?
No, right now it's doing some data analysis of the data. Let me say also that we have, for instance, tried to write math papers, but these papers were not good. Antonio told us that the theorems were not proven, and yeah, these are very bad. Okay, so let me show you. So it has already written 2 codes, right? So this is, for instance, one. So you can see here. So everything here is written by it, right? So, I don't know if I don't even know what it's doing right now. But, all this code that, I don't know, 200 lines, everything written by it. And if you use like ChatGPT, this is probably not very surprising.
But
right?
wait, here definitely it's easy to check that, let's say, the code works, but how can you know that he's producing what he claims he produces?
Yeah, so it's going to make plots, and many people ask me this, is like, how do you know that this is not really cheating?
Not even cheating, but maybe he claims that he's computing, I don't know, a mean square, and he's computing another thing, or...
yeah,
in other words, at the end, you need to go line by line, or you have a way...
In principle, you should really check everything to make sure that what it's doing is really what it claims to do.
Okay.
But again, thinking for the future...
No, I'm not saying that it's a bad idea.
Really,
yeah.
So we're not going to go line by line here. So let me show you. So it has written already...
Because, for example, I'm extremely bad in learning the code that other people do. So it might be that the effort in going line by line with the reasons, let's say, with the line of reasoning of another person or agent or whatever might be consuming, no? Time consuming.
I agree.
Okay.
I agree.
Okay.
Yeah. Okay, so it has written already 3 codes. Let's see. Okay, so it's making plots. So you see, these are like, I don't know, CBS files that it's doing. This is, for instance, a plot that it has done. I don't know what is this. But, omega matter versus formation time and sigma 8. I guess this is like the distribution of the data that we have. And let's see, this is another plot here. This is, I guess, like the distribution of the different parameters, I guess. Yeah, histogram of raw feature distribution. Okay. Anyways, so it's doing, okay, so now it's doing a lot of plots here. This doesn't look very good, right? I don't know exactly if the red line is supposed to go in the middle. But you know, let's see at the end. Okay, so it's really doing a lot of things here. I mean, even for instance, this plot, right? If I would have to do this plot, I will not be able to do it even in 10 minutes, right? So, anyways, so this is like one paper. Let's try to write another one, because this is going to take...
but you still have to write the paper. Here you produce the data for the papers, right?
Say again, sorry.
I mean, right now you don't have yet the paper. You have... no, you have the paper?
No.
No, okay.
Right now it's doing all the analysis.
Okay.
It's writing the code,
Okay.
making the plot. And
Okay.
when it finishes this, we'll write the paper.
Okay.
Okay. So just to show you, the variety of this is another, let's say, thing. So, this is I'm using, I was talking with Ricardo about this. So this is data from gravitational waves, right? So this is like the recent event where there is this strange, let's say, gravitational wave event. You can ask Ricardo for all the detail. I don't work on this. But basically, there are like two different models. And here there are samples from the posterior. And my understanding is that people are still trying to understand what are the differences between these. So we are just basically describing the data, and we are just saying, try to analyze the data and write a paper with this. So let's...
The Monte Carlo samples.
Yes.
So it's already some processed output. It's not the raw data.
It's not the raw data. These are samples from the posterior.
So the posterior, some analysis, the
Exactly. I think you can also work with raw data, but yeah, it's not going to finish. So let's see. So project 2. So let's done this. And yeah, again, this is going to take some time. And the third thing that I'm going to show you. So this is something that we're doing with Urbano, right? So this is, for instance, a paper that has already been written, right? So Urbano gives me some data about some clinics in the US, if I remember correctly. This assisted reproductive technology, blah, blah, blah. And basically, the system after running, I ran this on the background, was able to already produce all these things, We have now this idea, the methods, and the results, and it has all the plots. So now what I'm going to do is just, given this, I just want to write a paper. I don't have to do the analysis. I already have all the plots and all these things. So I just want to write the paper. Okay, so you can see also. Please.
This is a bit silly, but again, you're using Gemini 2.5 Pro.
Yes.
And you pay for that, right?
Pay,
you're paying to show
pay.
every single one of these things to us.
Say again?
You're paying money
paying.
to do this.
I'm paying.
Okay.
That's why on Friday, we cannot do for everybody because, yeah, it's really not very expensive. Every paper is like $4 right now, US dollars.
So how you compare with the postdoc? It's more convenient this, right?
I mean, we will discuss this. It's not at the level of a postdoc, I will say. Right now it's the level of, I would say, undergraduate, graduate student. But this is part of the discussion. Imagine in 5 years where we're going to be with this. Okay, so the first paper, amazingly, I don't know why, but the first one is already writing the paper. So let's see. So project 1, I mean, my feeling is that probably it has done something that doesn't make any sense. Otherwise, it will not be so fast. Yes, please.
I was wondering, is this, like the inputs to all the models are the text of the other models? There's no multimodality of analyzing the plots of the images or such?
Yeah, there is a multimodality. So for instance, we generate the plots, and when we later want to write the paper, we pass the plot, and this thing is able to kind of read and interpret the plot.
Okay.
And yeah, we haven't done some more sophisticated things, for instance, for the initial prompt, you can imagine input papers or input figures or something that you write by hand or something like that, but for the future. So let me show you how it writes the paper. So, right now is, what is this? Is doing the keywords, the abstract. So, this is what is producing. And, this is already the abstract, you will see that the next thing that it's going to do is going to write the introduction. And, I was talking a lot with David about this. It writes, I think, for introduction and these things, much better than I think many of the students that I have, I will say. I don't think it will write, I don't think it writes maybe right now better than I do, or maybe some of the more senior people here, but it's not bad. It's not bad. So you see?
Does it do any references, or that happens later?
Yeah. Yes. So we have the machinery to put references. So here, I think we have put false, but you can put references. The references are not very good. I already tell you that, for instance, for those of you, when I write a paper using camels, it cites another person, and it's like, what? Really? So it's not good, but it's not terrible. Okay, so you can see more or less here what is going on. I think, for also the paper of Urbano is doing this. And let's take a look to see what found. So already in the abstract, we should have some information. Yes.
So here I really want an opinion from the experts about the abstract.
I think Raul is expert on this.
Okay. Okay. Now there is possibility. Yeah.
Yeah, I'm not sure. The abstract is very generic, right? I don't think there is really anything here.
Yeah, it sounds totally reasonable. Maybe it's not so very new, but right.
Yeah, it sounds boring, I think, but it's not unreasonable, I would say.
Yeah, but we have done in 25 minutes, right?
Yeah,
so, and if you see really, I don't know. I don't think there is really anything unreasonable here. And again, it might be a bad paper. I'm not claiming that, you really in 25 minutes, you write a paper.
Probably not very inventive.
Maybe, I don't know. This is, for instance, something that I don't think no one has done it, right? Because we have been doing this. This is really going from merger trees, from one single merger tree to the value of the cosmological parameters. I don't think that, for instance, this has been done in the past. We have already done it on the background, but it has not been done. Yes. Who is Anthropic?
Just about the authors, right? Who is Anthropic? There is Anthropic, Gemini, and OpenAI.
So basically, because we use like ChatGPT. So ChatGPT is part of OpenAI. OpenAI produced them. Google produced Gemini, and then Claude Sonnet produced Anthropic. So it's another company, let's say, producing these large language models. So okay, so it's generating figures here. And let's see. So for the paper Urbano, we already know that it's a reasonable one. If you look at this, and let's see, for the gravitational wave, control data. The one of Urbano, this is about medicine. The third one, this is already all the analysis has been done. So I'm just basically writing. Exactly. Okay, so yeah, let's leave it a few more minutes. It's gonna put all the figures. It's gonna take some time. And it's like half past. So maybe I would like to really discuss with you. These are, for instance, examples of papers that we have generated. And again, experts has looked at this, and they told us that these are good. These are like reasonable. So with Camille, we produced this paper about chemistry. And again, I think she has even a student looking at some of these ideas, some of these methods that it was able to produce by itself. With planetary science, I will say most of the papers were already good. I guess, depend on how many people that are working on a discipline, maybe, is maybe easier or more difficult. But again, for instance, this paper, some of these papers we are gonna really taking. The idea of this is not really to take this paper and put it on the archive, right? So if at some point you see a spike in my productivity, yes, be cautious. So, the idea...
If it were due to that, it would be even higher, the spike, right? Because 25 minutes a paper, so if you were using this, would be...
Yeah, we will discuss later about this. Also because, now, we can do this, right? And, people in machine learning has been doing this. So, this is about turbulence and something like that. And again, very, very deep. They were very, very happy. Biophysics, again, Anupani iterate a little bit on this, but it produced something that he was really happy. Biology, this is like very interesting. So again, I have no idea about many of these things. But this is on data about malaria. And basically, from what he told me is that he was able to really find some new correlations that they were not known. And, it's like, yeah, please.
So this was something I wondered earlier in the talk, which is that when you let this loose on real data, not synthetic data, aren't we about to have a multiple testing crisis?
Exactly. This is real data. Some of them are real data. Also how it's called this, like the comets. This is also from real data. In others, we have like simulations. But what I remember, I might be wrong with Pablo, is that we should probably iterate a little bit more on this. But if this conclusion really holds, we should go to the lab and check this, because this will be important. Okay, so this is another thing that you can do. And seriously, I almost cried when I saw this paper. Believe me. So basically what we asked here in the prompt was basically to combine ideas from quantum physics and with cosmology. So, as I told you, Pablo is working in quantum physics. I think he's going to Google now. And, we were trying to work together. And, sometimes it's difficult, right? We use like different languages. Sometimes I'm not interested in working with you, all these kind of things. So, we basically asked him to, and this is with the same data that I'm using right now, these merger trees. So I was telling, I think, to you guys yesterday that in quantum physics, they have these tensor trains, which, I don't know if you have heard about this, but my understanding of this is that, they represent quantum states as these very big matrices. And, these are big matrices, so it's difficult to work with them. So what they do is basically, instead of having this big matrix, basically represent the matrix as the multiplication of smaller matrices. That is much easier to work. So it's a very simple idea. I don't think in cosmology we have ever used any of these ideas. And we asked this team to basically write a paper about this, and it was very, very good, I will say. This is the first time, I believe.
No, go ahead.
Yeah, no, so I think, I almost cried.
Yeah. So my question is the following. So assuming that these machines are not conscious in our sense, so what are we doing as scientists? What's your take about this?
Yep. We should discuss this, yeah. I'm very worried about this. So, I've been
about us. Your word about us.
Yes. For those of you that are tenure, I think you are fine. No, but okay. So let me finish and let's go exactly to that point. Okay. So this is with, Urbano, and so this is, I think, what Aidan was. So, he gave us some data about these wearables, these kind of clocks that people put, and then my understanding is that they are trying to understand something about you from, these measurements of your body. So, it was something that he said was reasonable. Okay, let's go to your point. And, I'm very happy. I think you have already seen that this is able to write a paper. So these are the things that I would like to discuss. And really, everybody should express their opinion. Where do we go from here, right? I was telling Rogerio, machines are already better than us playing chess. Machines are better than us playing Go. Will there be a time where they will be better than us doing science?
Okay, goodbye.
But, right now, in 25 minutes, we are able to write a paper. Maybe it's not going to be good, but it's also not going to be bad. And again, we have shown this. What will happen in 5 years? What will be the case if that happens, right? It's very scary. Okay, also, what about papers, right? I can write 1,000 papers, I have an account in Flatiron, I seriously can write 1,000 papers in a few hours. Will the number of papers matter anymore? We still use the number of papers as a proxy, right? If you are in any committee, it still is a proxy, When you hire a student, when you hire a postdoc, maybe for faculty, it's still a proxy. So when you are able to produce so many papers, Does this matter? You know, maybe we will write blogs, or maybe just going to the point. Not sure.
I mean, maybe there is a sort of, how can I say, feedback mechanism. Like, so if you start to create thousands of papers, many of them will be bad, and so the new papers come out will be influenced by these bad papers, and they will produce again bad papers. So maybe there is a balancing at the end.
So that's a good idea. So I think, you know, the way that people are thinking about this is that, you know, you produce all these papers, but then you will filtrate them, right? You might be able to make an agent who is reading the paper and say, you know, this is a bad paper. I'm going to remove this, right? It's not going to be very difficult to do that. And then, you know, you only keep the papers that are good. And then, you know, it might, you know, then it might be able to train itself only in these papers. You know, it's like making a book, right? Making an encyclopedia by itself. It's very scary, right? And the same thing as with Go, right? With Go at the beginning, it was, you know, like us. We were able to beat it. I think today we don't even understand Go. You know, it's astronomically better than us. Will there be a point where this thing is going to do science that we don't even understand? I think it's going to be very good for some things, you know, things like maybe, you know, things where you only care about if it works or not, maybe things in medicine.
Do you think that consciousness is just an illusion?
Consciousness is?
An illusion? Because if these things are doing, if these things are doing science, and, you know, science in principle requires imagination and requires many things, and they are doing better than us, what's consciousness after all?
That's a good question. If anyone wants to answer, there was. I should ask the agent. Yes, I agree. There was a question there.
So context, okay? Nathan here asked about, no, but this is doing data analysis only, and you said, yeah, essentially, yes, it's not yet doing, I don't know, theoretical physics or mathematics. Fine, and then he left. I do data analysis, okay? So I'm already feeling a lot more pressured for this. But then this comes back to the fact that we should ask ourselves, why do we do science? So I work with I work in the LHC, so I work with humongous data sets. We will deploy these, okay? I'm positive that we will deploy this for the simple fact that our bottleneck is the fact that we don't have enough people to do all the analysis and all the correlations that we want.
Yep.
We have too much data. So then, okay, we deploy this. We find all possible correlations of everything with everything. This is good, right? We want to find the answer in the end. But then this is the question, is this really what we want? Because this is the equivalent of, quote unquote, selling our soul. Are we ready to give up the way we do science today to actually speed run our way to the answer? If we, physicists, us, right? If a devil or some AI appeared over there and said, hey, here, I give you the answer. Here's the question of everything. Would you take it? Or would you still prefer, yeah, me too, I would take it too. Or do you prefer to keep this life of lectures, conference, so on? Exactly.
Like, first of all, I think these models were trained using like our data, so we collectively created like a pool of knowledge where these AI models are trained on. So I don't think we should be really worried about being replaced, because I don't know whether AI could invent, for instance, general relativity back in the beginning of the 20th century, and sorry. Me neither. Yeah, oh, sure. If we think about regression problems, for instance, where AI is used to do things and make new predictions, you cannot trust their results when you're extrapolating. So I think AI is great to explore what we have already built as mankind, but our purpose is to explore new things and create new things and push the boundary of knowledge. And so, yeah, I think that's it.
Yeah, no, that's a very good comment. Let me go to this. So it's very unclear to me if AI cannot produce new ideas and produce new knowledge. People have shown, if you go to AlphaFold, and for instance, think about the Go, right? Initially, it's our data. Now it's able to produce new movement that no one ever did it. I'm pretty sure that whether it's going to be able to produce general relativity, I don't know. But imagine in 10 years. So it's very unclear to me. That's exactly the point, right? Whether this is just doing some simple analysis or whether at some point it's going to do better than us. It's very unclear to me. Raul.
So I'm not so worried about the motivations. I mean, anybody can have any motivation they want. I'm interested in the result in the end. And, you have plenty of infinite crappy papers these days without any aid or from AI, right? So, I mean, I think the question is, how can we steer this in a way that incorporates new ideas? So suppose that you have a new idea that's nowhere, or at least not in any recognizable way out there, right? And you want to communicate that and make your agent know about this and incorporate that, and then on top of that build on things. Is this something that is already possible? Because what you showed here it wasn't like this. It was just like taking what's out there already, all the documentation, all the codes, all the data, and then building something on the top of something that there is already a base of knowledge. What about new stuff? Can we, in the possession of new idea or a new data set, can we ask it to incorporate that in a meaningful way, or this is still hard?
You mean, for instance, with new data set, all the thing that I'm putting here is ChatGPT doesn't know, right? Because this is data that is private. So ChatGPT has never seen this data. So it's able to work with new data. I mean, this is really everything is new here. All these papers are new. For the first thing, for new ideas, I think it's the same. It's a little bit is like this, right? I mean, to some extent, right? If you say, okay, I want to write a paper about quantum physics and cosmology. Again, I don't think no one has ever done anything like this, and it was able to do it. So, if you have an idea, you can, in principle, just put in the prompt, and, I mean, it has to be seen, but it should work, I would say.
Sorry, just a follow-up.
Yep.
I saw in your first instructions that the description was not only a description, but also a series of prompts for what not to do.
Yes,
right?
yes.
And this is also critical here, right? It's something that we have to learn about. I mean, we do it to ourselves, like we do not want to go in a certain direction. So we have to be able to tell this, and we don't know a priori in which ways they can go nuts or go in a tangent in a crazy way. So we have to learn about how to prompt this, right? So it's not like prompt engineering is dead. It's just that we have to be better at it no matter what we do, right?
I completely agree. But you can imagine having agents checking this thing also for you. If this thing deviates a lot, that's a little bit what we do. Here we have like tens of agents. And many of them, they are only just checking that what the agent was supposed to do is really what it has done. So I think there are ways about this. Okay. Let me just show you quickly, 1 second, because he wrote the paper. So let's see. I just wanna. That was the purpose, and I managed. So let's see. Maybe this failed. Okay, this is also writing a paper. Amazing. This is the first time that I write too. I've been doing this for a while. You can imagine now. Sorry, this is project 1. Oh, it's still doing like preliminary version. But yeah, I mean. So this is the entire paper. So let's look at the plot. So you see, it's like a normal paper, really. So you have the plots, you have the captions. I don't have references, but I can put. And this looks like plots where there are some correlations. So, the R is not so bad. So probably, it has found some kind of correlation between something in the merger tree and cosmology. And I'm very happy. If anyone wants to really look at this in detail, we can look at this.
Yeah, but this is something that we know for a long time. Correlation is not causation, and our goal at the end is to find. I mean, this is something that I always ask. Is there a way to learn what the machine has learned? That is really the moment in which you do something more than just extracting things. Is there a way to understand what, for example, in Go? In Go, you say, now they do movement that we wouldn't imagine. Can we understand the logic that brought the machine to guess this movement that we wouldn't imagine? That would be really probably the the moment in which...
Yeah, I mean, what I can say is that here, in principle, is explaining you everything, right? So if you read this carefully, it's going to tell you that, I have done this, this is what I reached. It's maybe not, maybe explaining you in detail, but...
Yeah, now we have many questions over there. Yeah.
Yes, please, please, please.
Okay. Well, an important thing, I think, with regarding conscience is maybe conscience is sufficient to do science, but maybe that's not necessary. Mm-hmm. So other types of just from the sheer amount of structure there is in all written language from the 1600s to today, there's enough unexplored information that these models can harness and to give things that are new, but in a sense they were already hidden in the huge amount of structure in that type of data. And as long as science is a game, these things will win. So is it a game?
I think so. That's a very good comment. Many of the things, for instance, many of the things that I've been doing in the last few years, right, is taking ideas from machine learning and applying to cosmology. Really, that's what I have been doing and what many people do. So, these things knows already way more things than I do. And so that's why this is kind of, or combining ideas from different fields. Maybe in biology they do something that we don't know. And, so exactly, yeah.
So, I mean, at this point, these can, do data analysis and write good papers, but they aren't going to go into the field. I guess in cosmology, you can give them control of a telescope or something. But in most fields of science, they aren't actually able to do physical research. Actually, quite far from that in some sense. So, I mean, at the moment, this seems, as I said before, like many labs, in sociology or medicine or whatever, you do an experiment, you measure many, many, many parameters in your experiments. And then one of the crises in science right now is that you try many ideas to explain your data. You try to find different ways, different angles to look at it. And if you have enough postdocs doing that, you find some spurious correlation, you get your p-value, and you publish. This seems like a machine to make that a pipeline you can execute in about 20 minutes, So with real data, I think there's a big danger with this, no? I mean, it's going to cause every lab that has any temptation to make this happen, just forget about the statistical corrections you need for multiple testing, given data that's difficult to acquire.
Absolutely. And this was our initial motivation. We have these simulations like CAMOS, it's a petabyte. People have written 100 papers. I'm sure you can write 1,000 papers. But you always need someone to do this. I think with this thing, you can really explore the data way much better. Way much better. And yeah.
Okay, I have two comments. One is that I think I agree with Raul, right? If this kind of thing completely causes some kind of inflation on this kind of paper, is doing good, right? Eventually, if you're just making it a minor thing to produce just the application of some known method to a new data set, maybe with a bit of twist here and there, a less of a paper than something more original, that's a good thing. That's not bad because to be honest, a lot of really bright students have losing too much time doing exactly this, right? And if they have to find something else to do, maybe that's a good thing, right? Because machines are just doing data analysis and not original data analysis, right? You could actually be very creative at data analysis. But if you're just applying a method to a new data set, if we can do that automatically, I think that's a good thing. Now, about if these things will ever get the capability of having new ideas, right? A lot of argument that I hear that they would never be able to is that they are just interpolating, right? And I think the hidden assumption there is that we are able to have new ideas that are not just interpolating. And I'm not completely sure that is true, right? If people think, I don't know, they made up mermaids, right? That's an original idea, or it's just the interpolation of a woman and a fish, right? Same for a dragon or any other of these made up things we do, right? If we are just interpolating too, right? I mean, if you interpolate enough, you mix different enough ideas for long enough, eventually you get to a place where they look original, right? You take a caveman and show some of our ideas to them, it will look very original, but if you follow the story of these ideas, it's just very tiny mixings of other things that are around. If that's what we're doing, then I see no problem that eventually the machines will do it too, right? And then there's a real question there. One thing that is worth mentioning, I think anyone that is following AI has heard this argument before, but maybe not everyone is, right? People still play chess, right? Actually, people watch chess games with the same interest they always had, right? And nobody wants to see two machines playing chess. They want to see two champions playing chess. Still interesting, even if we know that you could bring a machine in and win the game easily, right? So it's still interesting, despite we have a better way to do it, right? So that's one point. Now a question, since we're supposed to ask questions.
But let me just maybe a small comment for this. But some people, I think, maybe for chess is different, right? Because it's just really a game. But for instance, if you work in agriculture, right, and I don't think people.
Oh no! Things that you need results for. If these machines find a way to cure even one kind of cancer, we don't care. Right? We just don't care if a human did it or not, right? We want the cure. That's where this question by Tiago is, I think, pointless. It doesn't matter if you want the answer or not. Someone will want the answer, and will go on TV and tell you the answer, right? So it's a theorem of over-present spoilers, right? You get the spoiler. It doesn't matter. Someone will get the answer, and will tell you the answer even if you don't want it, right? Especially for applied things, right? That's one of the arguments, right? If you don't do AI, someone else will do it, and of course, if it's related to military stuff, you might be in trouble, right? But now the question, right? Some years ago, one of the things people were trying to do with AI was symbolic regression, right? Getting equations. Give me a data set, and you try to get an equation that explains that data set. There was this paper by Max Tegmark a few years ago, was called Feynman AI, and this thing was a big deal because it was saying that it could get every equation in the Feynman books, but then it disappeared. It didn't go anywhere. You know what happened to that?
Yeah, I've been also working a little bit on symbolic regression. I mean, for things that are very simple, maybe like, things that are very well known, these things work very well. People have, for instance, able to recover neutron law just from observing the periods. For when the data becomes more complicated, usually, you get an equation that is gigantic and interpretable. You can ask Natalie. I mean, she has a very nice paper with an equation that works amazingly well, but we don't even understand why is that. But you can imagine that these agents might use these tools, right? They might propose an hypothesis, get an equation. If that equation is maybe ugly, iterate, and maybe they will discover general relativity. Maybe not.
So I have a comment actually on this. It's not a question, but I think it's interesting to see that in the past when technology, it's a discussion we had in lunch, right? But I want to bring it up. So in the past, when technology arrives, it was starting to remove all the labor, the stupid jobs you can think, right? The laborious one, which was very boring, not using, and people thought that these people will be out of jobs soon. But with AI now, what's happening is that they show that these jobs are harder to replace than the intellectual jobs. The intellectual jobs are being easier to replace. So maybe now it does data analysis well enough, better than us, and maybe it doesn't do math yet, or maybe it doesn't do philosophy. But I think it's naive to assume that it will not do it. We don't know, right? It's really unclear. And it might be that it does better than us. And then it becomes, more philosophically important questions that maybe it'll give you an answer that you don't know and tell you, some new discoveries. But at some point, if it goes this way, we're not understanding what they're doing, how they are reaching these discoveries and what's going on. And then we're going to be just observers to life, right? We're going to not be any agent anymore, to use the word that is catchy. We're going to just be looking around, and everything's going to happen, and you're not even understanding why it's happening. Like, people don't know how the cell phone works, right? So people don't even know how gravity works. They think the Earth is flat, and you get to this, extrapolating this, for the whole generation. It's very worrisome, and I think it's very worrisome. So now, maybe it's the case that what they can do is go in the lab, right? Because they don't have the hands to do the stuff, so we do it. But, I think things are moving very fast, and it's naive to think, okay, then we are fine with this level, and let's keep this way, and it's okay. And things is moving so fast, so it's. I think
exactly that's the scary thing. Yeah,
I'm also with Paco to say that it's very scary, and then we should be having this discussion in a much more broad. I mean, scientists, a small minority of the population. The economic forces behind this are unstoppable at the moment. So it's really complicated.
Yeah, some people say that maybe this thing is going to do science, and we will only do the plumber. Like all the dirty stuff that they cannot do right now. It will be terrible.
I don't think we should welcome these new overlords.
And I think after all these questions, I think it's time to ask what the role the philosopher team plays.
Yeah, so exactly. So the philosopher is basically discussing all these things, the ethic questions, what this technology means for science. But also even, we haven't talked about this, but even the way that we train new generations. I was talking with David, with Gonzalo, with Rogerio. For instance, in my case, these days I don't feel so compelled to work with the students, and the graduates, because this thing is so good, right? Seriously. You can get an answer already in 1 hour. You can iterate with it. So, and this is happening. Some people told me that, for instance, even these days, at least in New York, people working in law, apparently there are like senior lawyers. So again, that's what I was told. I don't know if it's sure. It's like, there is like the senior laws and there is like the junior laws or people entry. So usually the people entry, they do kind of like the most, maybe basic thing. And then the senior law lawyer will review this thing. And apparently now all this law level thing is being done by, large language models. So basically it's very hard to even find a job for this law thing. So there are only like very high level senior people and ChatGPT. So, and this is maybe what is going to happen to us, because if, so there are also these kind of ethical questions, it's like, again, but the philosopher was very happy with all these things, a lot of things too.
Okay. I think one important point is all this company training with the real papers, and it's available on the internet. But the point is, training, sometimes I see news about don't pay for some journals for access to the papers, only take the papers, and when you try use these tools, he say, oh, you need to pay money, but you training and not pay money for this. And the another point is, I don't know, if I'm write some paper, I don't like the one machine used for training. And this company don't ask if I would like or not to use my paper. I saw sometimes the people writing in the LaTeX some tasks for if one machine try read your paper, this like okay, erasing this, because this is another point. So it's amazing this can write one paper, but about the community. When you try use these tools, I think need pay. It's strange, no?
Yeah. This is another ethical question, right? People with money will produce more papers than people without money. But also people say that, even today, even without this, let's say, technology, I'm able to run more simulations than probably all of you here, right? So already the system is not equal. Whether this is going to increase or maybe make it more flat, because, it's only $4, right? It's not really... But yeah, that's a good question.
One question I had is, one way to check whether these tools can produce new knowledge, new theory, for example, would be to put them at the crossroads that humanity faced sometime in the past. For example, via the experiments of the data that led to quantum mechanics, and see whether it finds that solution or maybe alternative solutions to quantum mechanics, if it can develop a theory. And now I would like to know if that has been tried, if it's possible, if I guess you have to feed the AI with limited knowledge or something, And what happened if it diverged from the solution that humanity found, or it found the same solution?
Exactly. So many people ask me exactly this question. You know, it's like, for instance, if you train one of these models with all the knowledge until the beginning of the 20th century, we'll be able to discover general relativity, all these things? Yeah. So, I mean, training this thing is not easy, right? You need to be Google, OpenAI, this thing. It's incredibly expensive. You know, I was talking with Raul. It's like, I don't think we will be able.
The only reason these things are working nowadays is scale, right? You're training them on the whole internet, right? There was not this much data. If you go even to the 60s, there won't be enough text to make such a smart LLM, right? And if you train it with the internet of today, we will already know quantum mechanics. No, but it already knows quantum mechanics. That's the problem. Right? And then you won't be able to separate because it was trained in text that mentioned.
That's what I think. I don't know if that has been tried, because that would be an interesting thing
As far as I know, no, has not been tried, yeah.
One thing that might be related, or I'm not sure, this is something that I vaguely remember from a long time. If I remember correctly, machine learning somehow relearned the theory of chess with the same developments that we did. Like, for example, the gambit initially was accepted, then after a while started to learn, no, maybe it's better to reject it. So it seems that there is something intrinsic in this learning thing, such that the machine relearn again the theory in the same way. But yeah.
Yeah.
And that was without using internet, because it was just the agent playing against himself. It was not connected with the external world.
I see.
Okay.
Also, someone should take of the time. Okay.
Yeah, let's put the boundary in 15 minutes from now.
Happy to stay here. We have time to write more papers.
So, typically, LLMs, apart from hallucination and so on, they struggle with doing actual calculations. From what I understood, using retrieval augmented generation, one can diminish the hallucinations and perform data analysis and so on. But have you heard of trying to train agents with Wolfram Mathematica so that they can actually do calculations in practice?
Yeah, no, you're right. Tomorrow, I think we will talk about, for instance, we will talk exactly about how to do mathematical operations, with agents. Like ChatGPT is not good for that, but you can improve as you know very well, you can write an agent for that. Yeah, exactly.
With respect with what you were saying about chess, the machine can learn it's playing against itself, but there's a difference to science because in chess you have immediate feedback. You either win the game or not. And in science you might experiment with data and you don't know if that's correct or not. That's a big difference between learning just by playing with itself.
Yeah, it's true. But you do. The data is there. The very first thing that you have to do is get all of the data that you choose. You know, then
they are waiting for a long time. So, okay. Yeah, just I think answer one of the questions back there. You can drip down one model to another one, so you can use what you have to generate another model that's doesn't know about quantum mechanics or something like that. So it's possible. So he said, it's pretty expensive. But one question and comment I have related with Thiago's comment is that, and I want to know your opinion, is if you analyze, let's see, we have petabytes of data. If you analyze all that with some models like this from 5 to 10 years from now, and we find a new physics or something, the AI find the new physics, like the AI also already find some new proteins, like the AlphaFold that won the Nobel already. And my question is, okay, we are assuming that there is a roof for the knowledge. So I'm believing in that sense that if you answer all the questions, there will be new questions. So I think we can accelerate the science, but we'll never reach to the roof of it. So that's my opinion on that, what Thiago said. So
I agree. But the thing is that maybe at some point we will not even understand, because it's so high level or so complicated that we will not even be able to understand even the questions that we are formulating. Maybe the agent is able to understand even the question, but maybe not even us. It's like right now with Go, right? We don't even understand the movements. So, could be.
Okay. So I have a question and comment, because right now we're already seeing the environmental impact of using AI. So like we see that, I don't know, cities that are going without power because the power is using for the computers. And of course, just the scientific community, we can't like put limits on those big companies and all, but like the responsibility of when we develop a tool, like this one, for example, if you're thinking about that, like, is it going to be public? And you're saying about like in 10 years or even right now, we can write hundreds of papers, but that has an impact. And if you're thinking about those things, like how can we limit or I don't know, because we think about 10 years from now, how it's going to be. But 10 years from now, it's going to be like, the impact is going to be much bigger, probably.
I agree. I mean, what I heard, I think, from David, is that even Google is now trying to build nuclear plants so yeah, this is a very good question. Some people will say that, if I'm able to write a paper that makes sense, and this is what, let's say, a student is able to do in 1 year, maybe still, this will be beneficial. But yeah, the economic cost of training this thing is gigantic. Yeah. So this is a question for the philosopher or some of you. But it's a very important thing. Yeah. Maybe this is the cause of progress. I don't know. Yeah.
Hello. I want to ask about the other side of this kind of about these companies.
Yeah.
OpenAI, for example, we say always it's going to improve, but they're only training they have their hardware side. They're improving the hardware side. I don't know. What do you know? What's going to change? What they're going to improve in the future in 10 years? They're going to only train with more data, or?
My understanding is that they have already trained the whole internet, right? So my feeling for this is that they might train on new data, right? If some of these papers are good, and this is new knowledge, this is a new bit. And if you are able to produce millions of papers that are good, you filter down, maybe you will train on these things. But again, I don't know. Yeah.
So only improvement is going to be more training data.
Yeah, I mean, if you think, for instance, about how they train to play chess and Go, this is, I think, the way they did, right? They train on all the data available, and then it was basically on data that this thing generates by itself. So I will not be surprised if for this is the way to go.
Okay, let's try to reach, let's say, other 4 questions. Here I have 3. Maybe we can go with 1 there, and then we put a cutoff, otherwise we go forever. So let's go with, Jaru, since you are there, go with Jaru.
Yeah, just as a follow-up to that, I mean, my understanding is that there are really substantial problems with training on generated data, because unlike chess and Go, the feedback is not obvious. Like, again, if you can fit with a millionth degree polynomial, but whether it's a good, whether it sounds like natural English or not is not necessarily true. And that, I mean, it's true that for the last years now, these companies have had a lot of trouble improving with the normal scaling that they relied on the last decade. And it's these kind of techniques of having multiple models talk and review each other's work that is basically responsible for all of the progress and the quality of the last 2 years or so. Okay. And so it'll be interesting to see if this kind of innovation in the architecture and the engineering around the sides can replace the decade of data growth that we saw lead to these big breakthroughs in the last decade. But I mean, it's not obvious that the scaling will continue.
Okay. Yep.
With all these things, I'm going back to basically what happened to industries that already kind of went through a history of domination by AI. Some people like mention chess and Go, but I also think about what happened with images, for example.
Within what?
With images.
Images.
Like, one of the, like at first was like, oh yeah, the 6 fingers, and we are laughing here like the plots, so that don't make sense. That's a parallel. And now the next step I'm thinking about, at least, is the flooding of every system that we have to like check papers and accept to journals. And okay, if there's an image on the street of an advertisement for some food, and if I see the details, so I don't know, I see that the lettuce is purple, it's not that big of a deal in some sense. But if, for example, there are papers that are being accepted to journals and in the archive that are perfect until you see a detail, and that detail collapses the whole concept of the paper. Do you have any perspective on that problem?
Yeah, no, I don't know. Raul was saying that there are a lot of very bad papers already there. But yeah, I think it depends on the user. You know, I've been talking a lot with Mr. David Spergel, right? He's my boss. Initially, you know, he told me, it's like, oh, you are going to flood the archive with bad papers. I don't think this is going to happen because, you know, I mean, to create something semi-reasonable takes 25 minutes, right? I don't think really anyone is going to be so lazy to just do this. You probably will want to iterate a bit. Yeah, I guess it depends on the users, right? There will be some people that are going to use these kind of things, but someone also asked me, by the way, this thing is going to be public available, and on Friday we will use it. So, yeah, but I have the feeling that it's going to improve the quality of the research.
So I think we could keep coming back to the question of feedback and benchmarks and scaling and so on. It's hard for me to see how we could ever give feedback to an LLM like ChatGPT, whatever version, about what constitutes a good paper or a crappy one. It sounds difficult, but it's key. I mean, the way that we do research is a feedback loop. We learn to do better by having criticism, which is well grounded on facts and, you know, from external people, right? So it's hard for me to see how this is kicking in now. I mean, it's one thing to train an LLM with tokens which are sufficiently small and you have infinite numbers of them or near infinite, but then as you get larger and larger, you get to the level of a paper, how do you actually, now it's much harder to see. So my question, so I have an objective question now. If I get, let's say, an open LLM, put in my machine, and at which, is it even conceivable that providing feedback on the result, and not the parts of it, the result, is it conceivable that this improves that in any meaningful way, or this is not the game right now? We're talking about making things which are not nonsense, and we are very far away from the time when we can actually provide feedback and improve that by giving human, meaningful feedback.
Yeah, no, but Raul, this is the way that we already train the LLMs, right? So LLM is basically, you know, is predicting the next word, right? It's a trivial, super stupid thing. But the way, you know, once this is trained, what people do is this thing called like reinforcement learning by human feedback. So the idea of this is that, you know, you have the LLM, you ask a question, and it's going to give you, like, for instance, 10 answers. And there is a human and say, okay, this is the best answer, right? So basically you say, okay, this is the best answer given this question. And then you use this reinforcement learning to basically try to guide the system towards these questions. So I think for this, it's going to be exactly the same. You know, if we tell this is a good result, this is a good paper, we will improve the models by that.
No, yeah, but the question is about scaling. If you go from a small token to something which is larger, like a paragraph, or a question, like the one that you're talking, that has an objective answer that can be measured, you're talking about very close to the small tokens that you use to just make speech, natural language, right? What I'm asking is the connection with the building blocks of that LLM, they start to get more remote from the building blocks, right? So is that I mean, what you're talking about, of course, is providing meaningful feedback. And I'm talking about objects like papers, which get together many of these questions together, and each one of them may make perfect sense, but as a whole, they may be meaningless. Is that feedback ever going to seep down? We're talking about back propagation of that feedback, which is far at a much later layer to the first one. Is this something that we are very far from it yet?
That's a good question, Raul. Yeah, I don't know. Yeah. I don't know, yeah. Sorry, that's my, yeah. I haven't really thought about this, and I'm also not an expert on how you actually train these things, so we can talk later if you want.
Okay, I think we are over. I think I never chaired a colloquium so entertaining and so, let's say...
it wrote 3 papers at the end, you see?
Provocative, and also with so many questions, comments, and so on. The gravitational paper is done? It's very nice.
Yeah, it's nice. I'm happy to share with anything. So this is the paper of Urbano, you know, for these clinics in the US.
Okay.
Yeah, but this is only writing the paper, right? So this is easy. The gravitational wave, we will send to Ricardo. I already sent 5 papers to him. Like, seriously.
Takes more time to read them, right?
That's what I'm, yeah. But you will give me feedback. Again, some papers are very bad, really, but... Yeah.
Okay. I think it's time to wrap up, so let's thank our speaker again.
Thank you.
Next year, the talk will be by an agent. Okay.